All right, so we're coming from composite functions, and we're going to go to one-to-one functions. Okay, so a one-to-one function is if any two different inputs correspond to two different outputs. So we have functions that can only have x's that are different, that can't repeat. One-to-one functions also have y's that also cannot repeat. So the same thing happens. No x's can repeat and no y's can repeat. So it's kind of nice for us to remember here. So here's my set, 2, 6, -3, 6, 4, 9, and 1, 10. So I can still write domain and range for this. So domain 2, -3, 4, and 1. That's how most of you would write it. And range is 6, 9, and 10. Okay? Because 6 repeats, and essentially there aren't 4 domain pieces to 4 range pieces, it's not one-to-one. Okay, so we have something called a horizontal line test. We had a vertical line test. We also have this horizontal line test. So I'm going to write this out, but it's the same idea. So it says if every horizontal line intersects the graph of a function f in at most 1 point, then f is one-to-one. Okay, so here's a function. You'll get a couple of these for a graph, or maybe one, depends. So this one's getting lower and lower to the left, but never quite evening off. So it is one-to-one. Remember, I used to use a piece of paper on the chalkboard. You could use a pen, same thing, same idea. But this time we're looking at horizontal lines. So here's one horizontal line, here's another, and we're not intersecting in more than one place. So it's one-to-one. Okay, so we're headed towards something new, which is why we had to introduce one-to-one. Here's another set, -3, 5, 9, -2, 2, -1, 11, 0, -5, 1. Okay, so they want you to verify that it's one-to-one first. Okay, you could just, again, look at it, see if there's all different x's, see if there's all different y's. And then they want you to tell what the inverse is. Okay, so the easiest way to do the inverse with a set is to write the squiggly bracket and just flip the x's and the y's. So we get 5, -3, and we get -2, 9, and we get -1, 2. And we get 0, 11, and we get 1, -5. Okay, and then we would take domain and range from the inverse set. So domain would be 5, -2, -1, 0, and 1. And range would be -3, 9, 2, 11, and -5. Okay. So spurring from that, I'm gonna make sure I have enough room. I'm gonna go to new whiteboard. And we're building from one of the problems last section. We're gonna verify the inverse relationship. Okay. And then it asks on my math lab to give any domain values to be restricted. Okay, so here's my two functions. I have f of x equals 3x plus 4, and I have g of x equals 1/3 x minus 4. Okay, so to verify the inverse relationship, I need to do f of g of x and make sure it equals x, and do g of f of x and make sure it equals x. And I need to show all of the work if it were to pop up on a test. So we showed the work last section. We're going to show that the work's a little bit longer in this section. Okay. So I like to, again, write everything out. F of 1/3 x minus 4, so I replace g of x. Okay. And this piece right here goes right here. So the parentheses get a little complicated on this. So I know that it goes 3, and then this whole piece goes in. So I'm going to put a bracket. 1/3 x minus 4. Again, this is the bracket that replaces the whole x piece, plus 4. Now I have to worry about simplifying. Okay, so how this one simplifies is the 3 would go in. Okay, the 3 goes in times the 1/3, and they cancel out. So I'm left with x minus 4 plus 4, which then gives me x. Perfect. Okay, g of f of x is not going to give me the same in terms of how it works out. So I get g of 3x plus 4. So this goes in right here. Again, parentheses get a little complicated. So I get 1/3. Again, I'm going to leave the parentheses that it had there. I'm going to put in a bracket for the piece that I'm adding. 3x plus 4 minus 4. So I only put a bracket in for the misplaced, or the placed in x. Okay, so hopefully you can see what comes first. Here, what comes first is the inside of the parentheses, which means the plus 4 and the minus 4 are going to come first on this one. So I'm left with a 1/3 times 3x, which gives me just x. Okay, so the domain values to be restricted. Remember, you want to look at the very beginning when you plug something in. So right here, when I plug something in, I have no variables in the domain. I have no variables in the, in the denominator. And at the end, I have just x's. I have no variables in the denominator. So my domain is all real numbers. There's no restrictions or no restrictions. Okay. All right. Couple more problems we need to go through. All right, so on this one, it asks us to draw the graph of the inverse function and the inverse function is labeled f to the negative 1. So let me draw the original graph. Again, super great that I have different colors here. So I'm going to have the first coordinate at 1, 2, the second coordinate at 0, 1, the third coordinate at negative 1, 0, and the fourth coordinate at negative 2, negative 2. All right. In order to draw an inverse function, I'm going to do exactly what I did on the other one. I'm going to take the coordinates and invert the numbers. Okay. So my first coordinate's at 1, 2. So I'm going to put 1 at 2, 1. And my next coordinate is at 0, 1. So I'm going to put 1 at 1, 0. And the next one's at negative 1, 0. So I'm going to put it at 0, negative 1. And the last one's at negative 2, negative 2. And it's going to stay the same because it's just going to stay negative 2, negative 2. Here's my inverse. Okay. So one neat thing about the inverse function is that it will mirror itself over the line y equals x. So this is y equals x. The blue is the original function, and the red is the inverse. So again, just flip your coordinates. It's the easiest way to do it graphically. Okay, let me do a new whiteboard for the next one. So we're going to find the inverse. We're going to graph f inverse, and y equals x for f of x equals 4x plus 2. Okay, so in order to find the inverse first, so I'm going to find the inverse. Let's do that first. We're going to set f of x as y equals 4x plus 2. So when I flip the coordinates, I just make x, y, and y, x. Well, I'm going to do that in order to find the inverse. So I'm going to change it to x equals 4y plus 2. And I'm going to solve for y. So x minus 2 equals 4y. And x minus 2 over 4 equals y. That's your inverse function. Or 1/4 x minus 1/2. However you want to write it, both work. Okay, so that's my inverse function, equals f inverse. Let me show you a different way of graphing it, obviously. All right, so again, I'm going to graph my original function in blue. Let's draw some dots out here. 1, 2, 3, 4. I don't know how many need. 5, 6. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Maybe I need more. Maybe I need less. I don't know. All right. So I'm going to start at 0, 2, and I'm going to go up 4 and over 1. Okay. So that's my original line. My recommendation for doing the other is you could graph this line. That's perfectly okay. Or you could take the coordinates you just graphed. I had 0, 2. Let me do 2, 0. Obviously, this isn't super accurate, but that's okay. And then now I have 1, 6. Well, I'm going to do 6, 1. Told you I wasn't sure. 5, 6. 6, 1. Okay. And then I'm going to graph this line with my arrows. This is f negative 1. This is f, and again, I'm going to graph y equals x because it asked me to in yellow. As a dashed line, I believe that's how it'll be on my math lab. And again, if you graphed it correctly, it will cut it in half. You could fold a piece of paper and one would fold over the other one. Okay, one last problem. Nope, still in yellow. We definitely do not want to watch this in yellow. It would be very difficult. All right, 67. Find the inverse. And check the answer. Okay, f of x equals 2x over 3x minus 1. Okay, so I said on the other one, in order to find the inverse, first set y equal to 2x over 3x minus 1. So change it so it's y equals. Then we're going to flip the x's to y's and the y to x's. So we're going to take x equals 3y. Oops, not 3y. Undo. Whew, that would be bad. 2y over 3y minus 1. Okay, so I need to solve for y. Well, let me tell you, anytime we're solving anything with a fraction, get rid of the fraction. So we're going to multiply both sides by 3y minus 1. Okay, so make sure you distribute it to both. I kind of didn't draw a lot of room for that. So on the right side, it cancels out. On the left, so I'll write an extra line. I get x times 3y minus 1 equals 2y. And I need to distribute. So I get 3xy minus x equals 2y. And now you're probably like, well, why did you do that? You had the y's on one side already. I had to get rid of the fraction, trust me. So now I need to make it so that the y's are on the same side. The easiest thing for me, and I like to eliminate a lot of the negatives, is I'm going to add x over here, and I'm going to subtract 2y to the other side at the same time. I don't like a lot of negative numbers. So now I have 3xy minus 2y, and I have x over here. So I essentially flip-flopped the x and the 2y. Now I can factor out a y. Y times 3x minus 2 equals x, and finally I only have one y. I had multiple y's all the way up till this point. Last step, divide by the parentheses. Y equals x over 3x minus 2. That's f to the negative 1. Okay, it does always say on this problem, check your answer. And how you would do that is doing your f of g of x and your g of f of x. But nobody ever does that, nor would I ask you to do that after this super long problem. So don't worry about checking your answer. Just find the inverse. If you get it wrong and you're really struggling, then ask for help.